Hey, this is section 2.2, estimating limits. In this video, we're going to see what it looks like when a limit is approaching infinity. So if you remember, when it's asking for us to estimate the limit of a function, it's really just asking us what value is this function approaching from either side as the x values get closer and closer to this point of interest. And the way that we solve these types of problems is really similar to how we've been solving the problems in section 2.1. We're going to plug in x values closer and closer to our point of interest and see what happens in the function. So let's go ahead and go through this example problem. This is number 25 in your book. It's asking for the limit as x approaches for this function here. So like we just said, our first step, we're going to make a table and plug in x values getting closer and closer to our point of interest from either side. So conveniently, I already have a table here right here for you. So it's approaching 4 from the left and the right-hand side. I'm not going to go through this entire table, but I'll go through the first line with you. So let's say we plug in 3.9 into our table. We go over here, plug in 3.9 wherever we see an x, and when we solve all this out, we're going to get negative 1,000. So let's put that in. And then you just go ahead, do that for the rest of your x values, plug them all into your function, see what comes out. And then step 2, super hard one, we look at it. So now let's look at our table, see what y value this function is approaching as the x values get closer and closer to our point of interest, which is 4. Okay, so looking from the left-hand side, it's going from negative 1,000 to negative million to negative a billion. So it's getting infinitely and infinitely smaller as the x values get closer to 4. You can imagine, we only went to 3 decimal places here, but imagine if we had hundreds of decimal places, 3.99 repeating. Imagine how small this y value would be. So as the function is approaching 4 from the left-hand side, it's getting infinitely smaller. It's approaching negative infinity from the left-hand side. But let's go ahead and look at it from the right-hand side, see what it's doing. When we look at it from the right-hand side, as the x values get closer and closer to 4, we see the opposite happening. It's getting infinitely larger as we get closer to 4. And same thing, we can imagine if we had hundreds of decimal places here, how large would our function be? So from the left-hand side, we have our values approaching negative infinity. From the right-hand side, we have our values approaching positive infinity. This is a case where a limit doesn't exist because the left-hand side does not equal the right-hand side, but the left side limit and the right-hand side limit both exist. So the way you write this is the limit as x approaches 4 of this function here is equal to negative infinity. From the left-hand side is equal to negative infinity. And the limit as x approaches 4 from the right-hand side of this same function, it's getting infinitely bigger, is equal to positive infinity. And that would be your final answer. But just for fun, let's see, what would this function look like on a graph? So let's say we were to plug in 4 into our function, what would we get? Well, we'd get 1 over 4 minus 4 cubed, that's 1 over 0 cubed, that's undefined. Gross. On a graph, what this would look like is, all right, we have our x value, 4, but here it's undefined, it's 1 over 0. That's going to be a vertical asymptote. From the left-hand side, our values are getting infinitely smaller. So that's going to look something like this. It's about to hug the vertical asymptote. It's getting really, really close to it, but never actually touches it. It goes on down for infinity. And from the right-hand side, we're getting infinitely larger. So it's going to be going this way up on the asymptote. So the limit at x equals 4 doesn't exist, but we do have a left-hand side and a right-hand side limit. And that's about it for this problem. Hope that was helpful.